To the chemistry edition of the Alkenes channel. My name is Xboku. In today's lesson, we want to look at functional groups and look at naming of compounds as well. Okay, now we want to look at alicyclic alkene compounds. Now, when we talk about alicyclic alkene compounds, these are organic compounds which contain carbon atoms which are in closed rings. Also, we can say that they are joined by rings and they have a name. That is what we call cycloalkenes. So, in naming of these cycloalkenes, we use the prefix cyclo to start with the naming. So depending on the structure that you have been given, we can go with the prefix here, which is what cyclo. A typical example is what we have here. Now this structure here is giving us 4 carbon atoms. This is what the box. So we have 1, 2, 3, 4. So 4 carbon atoms will give us butane. But we are saying that because it is a closed ring, we use the prefix cyclo. So that is cyclobutane. Cyclobutane. Let's pick another one. We can also have something like this. Counting the number of carbons, that will give us 5. 1, 2, 3, 4, 5. So this will give us cyclopentane. Let's do more. What about if you have 6 carbon atoms? So we have 1, 2, 3, 4, 5, 6. That will give us cyclohexane. What about if you have substituents on the structures? How do we go about it? So we are going to maintain the same structures, then insert other alkyl substituent or any other substituent and see how we can name this. So with the first one, let's see how it will go. Let's assume that we have CH3 here. Now counting, we have this one being on the first carbon, whether it is here or there. It is on the first carbon, so the name becomes methyl cyclobutane. That is for the first one. And let us look at the second one. What if you have CH3 here? Now, because the substituents are 2, then we can indicate the number to separate them. So we have 1, 1 for the substituent. So we can say that it is 1, 1 hyphen dimethyl cyclopentane. Good. So that is what we have for this one. We can also look at this one. We have CH2, CH3 here. What about if I expand this one? CH2, CH2, CH3. What can we say about this? I wish you could try this one for me. Okay. So let me give you some few seconds. Alright, I hope you are done. Now let's look at this one. Now with this, we are having an ethyl group here, which is E, and this is propyl, that is giving us P. So in naming, the rule says that we should use alphabetical order. So I cannot start the counting from here, 1, 2, 3, no. What I have to do is I'll start the counting from here, because in terms of alphabetical order, E comes before P. So 2 here, 3, 4, 5, 6. So that will give me 1 ethyl, 2 propyl, cyclohexane. Alright, so that is what we are going to get from this. Now let's try more examples. So now let us look at the last 2 sets of examples and see how we can name this. So we have the first one here, which contains bromine, CH3 and Cl. Now, according to the rule, we are to name this in terms of alphabetical order. So we cannot start the numbering from here, but instead we have BR. B comes before N and C. So 1, 2, 3. And in terms of naming, we are to arrange them in alphabetical order too. So we have 1 bromo, 3 chloro, because C comes before M. 2 methyl cyclohexane. So 1 bromo, 3 chloro, 2 methyl cyclohexane. Now what about the last one? This is Cl, that is what? Ethyl. In terms of alphabetical order, C comes before E. So the numbering will start from here, 1, 2, meaning that we have 1 chloro, 2 ethyl cyclopentane. Welcome to naming of alkenes. In the previous lesson, we said that alkenes have general formula CnH2n. So for us to know whether the compound given contains a double bond or not, we can apply the formula which is CnH2n. Now our main focus is on the naming of alkenes, but there are some basic things that we have to get right. Now when you take the number of carbons starting from 2, that gives us ethane in alkenes. But in our case here, because we are talking about alkenes, the ending, which is the N here, is replaced by "-ine", meaning the name for this carbon, that is the 2 carbon atoms here, becomes ethene. So we are following that to get the other ones. If you have 3 carbons, then that will give us propene from propane. C4 butene, C5 pentene. And this indicates that there is a double bond. C6 we have hexene, C7 will give us heptene, C8 octene, so we can continue from there, and that is something that we are going to depend on for our naming of alkenes. Alright, so now let's pick some examples. So we have CH3, CH double bond, CH2, CH3. We can also pick another one. Okay, now let's finish with the first one. So according to the rule for naming alkenes and alkynes, we'll talk about alkynes. The rule says that we are to identify the longest continuous carbon-to-carbon chain containing the double bond. Once again, identify the longest continuous carbon chain containing the double bond. Now, after doing that, you have to look at the position of the double bond as well. So let's check. We have 1, 2, 3, 4, 5, giving us the longest chain. We don't have any substrate on it. So that is automatically going to give us pentene. Pentene, that is the parent name. But we are saying that we need to consider the double bond as well. So we want to get closer to the double bond. Let's look at the root. So we started from left to right, from right to left. How do we get this? So let's see. 1, 2, 3, 4, 5. So starting from the left, I met the double bond on the second carbon. So I can say that from left to right, the name is 2-pentene, or we can say pent. Then we bring hyphen, we bring the number, and we bring the "-ine". pent2-ene. Let's look at the counting from right to left. 1, 2, 3, 4, 5. 1, 2, 3. We met the double bond, and that is going to give us 3-pentene, or we can say pent3-ene. But according to the rule, we are still depending on the rule for alkanes that we did. So according to the rule, we have to use the least counting number. So comparing these 2 and 3, the 2 here becomes the least counting number, which makes this one correct, and this is what? Wrong. So take note of. Alright, so we'll pick a second example here, CH3, CH with a double bond, CH with a substituent here, CH3. So how do we go about this? Please take note, the double bond gives you the direction, not the substituent. So you consider the position of the double bond first. So with this one, we cannot start the counting from here as we did earlier on. 1, 2, 3, that is too far compared to 1, 2, meaning that we have to start the counting from left to right. So 1, 2, 3, 4, 5. So per what we have here, with 5 carbon atoms, we have the parent name to be pentene. We have the number to be 2, so that is 2-pentene. But looking at the 4th carbon, there is a substituent on it. So we have to consider that, and that will give us 4-methyl 2-pentene. Please, if you omit the number here, that gives you an incorrect answer. We can also say that this is 4-methyl pent2-ene, and that is the same thing. With the same structure, let's do some few changes. So we can bring another CH3 here and take away this H. Alright, so with this one, we are maintaining the same numbering system because the double bond is closer to this side more than the right. So we have 2-pentene being our parent name, but on top of the second carbon and the 4th carbon, we have alkyl substituent, that is a methyl, C3C3. So the name becomes 2,4-dimethyl 2-pentene. Take note of that. Now let's look at the ring structures. How do we go about that? Okay, so I want to look at the last set of examples. We have a mixture of the cyclic and the branch ones. So looking at the first one here, we are still maintaining the rule. Consider the position of the double bond. So looking at what we have here, we cannot start the counting from here because of the double bond here. So that is going to give us 1, 2, 3, 4. So the name for this one becomes 4-chloro because of alphabetical order. We have to name this in terms of alphabetical order, and that is 4-chloro 3-methyl. This is a cyclic compound, so we use the prefix cyclo because of the double bond, cyclohexane. So 4-chloro 3-methyl cyclohexane. Let's look at the second one. We can also look at the second one. There's a double bond here, so we cannot start the counting from here as we did in Alkenes. So that will give us 1, 2, 3, 4, 5. So the parent name becomes cyclopentene, but there is a double bond here, which is 1, so cyclopent1-ene. Now let's look at the other substituent. We have 3, that is 2 of the bromine. So that will give us 3,3 dibromocyclopent-1-ene. Cyclopent-1-ene. So let's move to the next set of examples. We are moving to the next one. Now looking at this, we cannot start the counting from here because of the position of the double bond. So that is going to give us 1, 2, 3, 4, 5, 6. Meaning that the parent name is going to be a hexene, but it is on the first carbon. So that is 1 hexene. 1 hexene. Now let's look at the substituent. There is 1 on the third carbon, another one on the fourth carbon. But in terms of alphabetical order, B comes before C. So that is going to give us 3 bromo, 4 chloro, 1 hexene. 3 bromo, 4 chloro, 1 hexene. Okay, so with the last one, how do we go about it? I think you want to give it a shot, you can try. The system goes this way. So we still have the numbering starting from the left to the right because of the position of the double bond here. So 1, 2, 3, 4, 5, 6, 7, 8 here, and 9. The rule is saying that we should consider the longest continuous carbon chain containing the double bond, and that gives us the longest continuous carbon chain containing the double bond. So looking at what we have here, we have the double bond on the second carbon. So with the number 9, that is going to give us nonene. So that is non-2-ene for the parent name, non-2-ene. But we still have substituent. We have 1 here, another 1 here, and another 1 here. This is the least number. So we have 2, comma. When we get to 6, we have 2 of them. 6, 6, trimethyl non-2-ene, or we can say 2 non, something like this. With A here, that is H. That is giving you a 6. But if I change this one to A, down here A, that is going to give me a trans. So how do we name this when you have a 6 and a trans? A typical example is this. CA3 here, CH3, that is H. So with this one, it is the same number of carbon atoms that we have. We have 4 carbon atoms, but because of the arrangement and how they are being positioned, this one becomes what? 6. 4, that is 1, 2, 3, 4. So we have the double bond on the second carbon, 6, 2, butene. What about if I change the position of the substituent here or the carbon here? And that is going to give me CA3, C, double bond, CH3 here, H. Now looking at the position of the continuous chain, the CA3 here, CA3 here, that is going to give us trans 2-butene, or we can say trans-but-2-ene, and that is for the geometric alkenes. Now let us look at the naming of alkynes. In the previous lesson, we said that alkynes have the general formula CnH2n-2, which indicates that we have triple bonds in alkynes. So that is what we want to look at. But there are some basic things that we need to know. How do I know the name given to the alkynes? How do I even know that there's a triple bond in there? We can use a formula to determine that, as we did in the previous lesson. But the basic things that we need to know is the names, parent names given to these compounds. So if you have, let's say, 2 carbons, that is going to give us ethane. But because of the surface here, which is what the iron, that is going to give us ethyne. So this is no longer ethane but ethyne from alkynes. C3 is also going to give us propyne. C4 butane. C5 pentane. C6 hexane. You can continue from here. C7 is going to give us heptane. So these are some of the basic things that will be dependent on in terms of naming alkynes. Now let's look at some few examples. So with the naming of alkynes, we are still going to go with the rules that we started with for alkenes. And the rule says that we are to consider the longest continuous carbon-to-carbon chain containing the triple bond. We have to look at the least counting number as well. So with this one, we cannot start counting from here. 1, 2, 3. No. We can only start from here. 1, 2 because of the least counting number. Now with this one, the name becomes 2-pentane because we have 5 number of carbons, or we can say pent-2-ine. That is for the first one. Now let us look at the second one too. Starting the counting from here is wrong because of the position of the triple bond here. 1, 2, 3, 4, 5. That is giving us bigger numbers compared to restarting the counting from here. 1, 2, 3, 4, 5, 6. And that is going to give us hexane. So what will be the name of this? It is on the first carbon, so that is 1 hexane or hex-1-ine. Hex-1-ine. Now what about if you have 2 or more substituents on the chain? So according to the rule, we are to consider the continuous carbon chain containing the triple bond, then we look at other substituents, and the other substituents will have to be arranged in alphabetical order. So looking at the position of the triple bond, we can only start the counting from here. So we have 1, 2, 3, 4, 5, 6. It's going to give us 2 hexane. But what about the position of the substituent? B comes before M, so that is going to be 4 methyl 2 hexane. 4 bromo 4 methyl 2 hexane. We can say 4 bromo 4 methyl hex 2. I want to look at the last set of examples under alkynes. Now looking at the first structure here, we have to go with the rule. We have to consider the longest continuous carbon-to-carbon chain containing the triple bond. So let's see. Now if I start counting from here, that is going to give us 1, 2, 3, 4, 5, 6, 7. And that is going to give us heptane. But let's count from right to left. 1, 2, 3, and we are meeting the triple bond. So instead of counting from left to right, we can start from right to left to 1, 2, 3, 4, 5, 6, 7. The triple bond is on the third carbon, so 3 heptane. That is giving us the parent name. By looking at the chain here, which is a branch chain, we have fluorine on the 5th carbon, so that is going to give us 5 fluorothione. heptane, or we can say 5-fluorohep3-ine. Now let's look at the last one. It is obvious that the counting will start from the left. So we have 1, 2, 3, 4, 5, 6. We don't have any problem with this. That is going to give us hexane. That is 1 hexane because of the position of the triple bond. Now let us look at the substrate. We have 2 alkyl substrate, that is the methyl, with positions 3 and 4, and we also have another substrate, that is chlorine, position number 5. But according to the rule, we are to do this in alphabetical order, so it becomes 5-chloro 3,4-dimethyl hex 1-ine or 1 hexane.